Science was being done this morning at Cordova High School, all at the expense of our beautiful pumpkin, Karma.
Oh, yes, some very interesting stuff going on here behind me. First, take a look at what's going on. We can see not just what's left of our prize pumpkin, but some students getting right there in the middle of it. Probably some parents aren't going to be super excited about the shoes they're going to be coming home with, but they're going to be coming home with some pretty exciting knowledge and a physics lesson that was taught. So with us to break it all down is physics teacher Mark Reuter here. And Mark is actually the one who asked me to drop the bouncy ball and the soccer ball. So let's start with that. Why did you want me to drop those at the same time?
So originally I wanted to take a look at how fast the pumpkin was dropping in the soccer ball and the bouncy ball. And because gravity is nice and uniform, all three of them should have been dropping at the same time. So hopefully we have some nice footage of all three going at pretty much the same rate down towards the ground.
So anyone thinking just because the pumpkin was so much heavier, it would go faster, not true.
Exactly. We're trying to break people of that notion.
All right, and so what are the students doing right now?
So right now I have them measuring how far the various pumpkin chunks are from the center of impact. We're taking a look at the conservation of momentum, and when the pumpkin impacted, everything should have gone pretty much equally outwards according to the laws of Isaac Newton, momentum. Now, unfortunately, we're not able to measure the velocity of each chunk, but by figuring out how far away they are, we should have a pretty good idea about how much each chunk went to the left and to the right. And overall, there shouldn't be any difference between the two of them. The stuff that went to the left should pretty much be equal to the stuff that went to the right.
Exciting. So essentially, you're putting a practical application, not that people really drop a lot of pumpkins, but essentially showing your students that the laws of physics that you talk about in the classroom in a theoretical sense, they actually apply.
Exactly, and it's not every day you get to have a pumpkin explode on campus, so we're taking as much opportunity as we can to study this.
Absolutely. We certainly have Metro Fire to thank for that. We certainly appreciate all their extraordinary work. It was really fun being up there, guys. And so this is the end of our pumpkin. I don't know. I'm a little bit sad. We kind of got really attached to having it there in our backyard with us.
A little seedling.
Kind of a part of our family, but there goes our pumpkin. Just in time for Thanksgiving, right?
There we go.
And in time for pumpkin pie.
Yeah, imagine all the pies we could have made
In
there.
time for pumpkin pie.
Nicely done, Karma. Thank the students and the teacher for us there. And again, by my calculations, it should have been traveling at 36 miles per hour when it struck the ground,
That was
falling
awesome.
from 40 feet.
So cool. Thank you, Karma. We'll see you in just a little bit.
Poor pumpkin.
A fun holiday tradition returns to Folsom. Get ready for another edition of your